In the last chapter, we calculated the probability that a sample mean or a sample proportion should fall within some range. In this chapter, we're going to come at the same kind of problem from the other end. We're going to first define the probability, also known as a confidence level, and then compute the range of sample means or proportions that we could expect to see at that level of confidence. So we call that an interval. We call that, we're calculating this interval, this confidence interval, uh, in this case, a lower X bar and a higher X bar that would give us a certain level of confidence. Now, let's take a look at a very simple problem, problem 2 in your book. It's on page 361, and I'll show you what we mean here. So this problem says that I have a random sample of 50 items from a population with sigma of 6, and it resulted in a sample mean of 32. So let's just put in here what we've been given. The X bar, the sample mean, is 32. The sigma is 6, and the sample size, n, is 50. Okay, now in part A, it wants to know what the confidence interval would be for a 90% confidence. So we'll just plug in here, we'll plug in 90%, that's 0.9, that's our confidence level. Now alpha is always 1 minus the confidence level. So in this case what we're saying is we're 90% confident, so we're 10% unsure. Now we need to calculate our margin of error. And in your book there are several formulas that you can use traditionally to calculate this margin of error. But seeing as Microsoft Excel is mankind's greatest invention, that makes it very easy for us, we're going to use a function called confidence.norm to compute our margin of error. This just equals confidence.norm, and it tells us what it wants. First it wants the alpha, that's our alpha, comma. Then it wants the standard deviation, which is 6, comma. And then it wants the sample size, which is 50, enter. Okay, so our margin of error is our sample mean plus or minus 1.4, roughly. And so what is that? So our minimum would equal the mean minus the margin of error, and the maximum would equal the mean plus the margin of error. So there we see that if we were to take a sample and the mean was between 30.6 and 33.4, we would be 90% confident that that is within a range that represents the population mean. Then in part B and part C, it asks us for different confidence levels, so we can just change this. Part B wants a 95% confidence level. So you can see that as the confidence level is greater, the interval or the range gets wider. Okay? And then 99%. So we can be 99% sure if it's within this range. It's a wider, somewhat wider range. So that's pretty simple to compute, pretty simple to understand. Now let's take a look at a confidence interval in a problem revolving around a sample proportion rather than a sample mean. And for this we can't use our confidence.norm function, so we have to do a little more calculation. To illustrate this, let's look at problem 38. Problem 38 is on page 381. It says I've got a sample of 162 companies. I'm surveying their financial performance. 104 of them beat estimates, 29 matched estimates, and 29 fell short. Okay, and part A says, what is the point estimate of the proportion that fell short? Okay, so if I'm going to calculate the proportion, first I have to know the sample size, which is 162. X, or the proportion that fell short, is 29. So P bar would equal 29 divided by 162. So our point estimate for those that fell short, this is the answer to part A, is 0.1790. Now I'm going to make some changes for part B and part C, but this is the answer to part A, so I'm just going to copy it over here, 0.1790. All right, so part B says, determine the margin of error and provide a 95% confidence interval for the proportion that beat estimates. Okay, so the first thing I have to do is I have to change P bar to those that beat estimates. This 29 was the proportion that failed to meet the estimates. So those that beat the estimates was 104. So 104 out of 162, our P bar, our proportion, is 0.6420. Now, what we're trying to do is we're trying to calculate a margin of error at a 95% confidence level so that we can find a min and max for our interval. Okay, so we need to first calculate this problem in order to calculate this formula. This is our margin of error. So there's a few things that we need. One thing that we need here is P times 1 minus P, so that just equals P times 1 minus P. All right? We're going to forget about the error for a minute. We want a 95% confidence, so I'll just throw that in there. So that means that our alpha is, as always, is 1 minus confidence. Oops, sorry. And our risk, or that's alpha divided by 2 equals this divided by 2. And the reason for that, again, is because we're assuming that this confidence, or this P bar, follows a normal distribution. If we have 95% confidence, it gives us basically the tail on both ends of the normal curve, but we just want a one tail estimate, so we divide alpha by 2. Now we can calculate our z equals norm dot s dot inverse. So we can calculate the z value of this number using this. Okay, and so actually we want this is the tail on the right hand side, and we want to know the z value of everything else. So it's 1 minus this number. So our z is 1.96. So it will calculate basically within 2 standard deviations of the mean. Okay. Now I have all the information I need here in order to use this formula. Equals z right here times the square root of p times 1 minus p divided by n. Okay, so our margin of error is 0.0738. So if I know that, then I can calculate my minimum and my maximum at a 95% confidence level. So the minimum, again, just equals P bar minus the margin of error. And the maximum just equals P bar plus the margin of error. And that's my confidence interval at 95%. Again, I could change the confidence interval and see how that affected, I could change the confidence level and see how that affected my confidence interval. And that's the answer to part B. Now part C wants us to estimate a sample size that would give us an error or a margin of error of 0.05. You see, we calculated this margin of error as 0.07 using a sample size of 162. If we want to have a narrower range or a narrower margin of error, chances are we're going to need a bigger sample. So we're going to now calculate the desired sample size that we would need in order to calculate an interval that would give us a margin of error of 0.05. So I'm just going to punch in 0.05. And then I'm going to use this formula right here. If I was calculating the sample size for a sample mean, I would use this formula, but I'm calculating the sample size required for a certain confidence interval for a sample proportion, so I'll use this formula. So it would just equal p times 1 minus p, that's right here, times, times z divided by E, that whole thing squared. Okay, so if I want a margin of error that's that small, I need a sample size of 353.17. But I'm not going to be able to find 17% of a person, so I always round up in my sample size. And although that would be easy to do, Excel will do it for you with the function round up, and it wants the number that I want to round, which is this, and then the number of decimal places. And since I want an integer or a whole number, I want 0 decimal places. So that tells me that I need a sample of 354. Now, if I wanted an error or a margin of error of only 0.01, for instance, I could change this. And you can see that I would need a much bigger sample. Okay, but 0.05 is what it asked for in the problem, and there we are. So I calculated a confidence interval for a sample proportion, and I calculated the required sample size that would be needed to calculate, to get within a certain margin of error. So I hope that helps you with Chapter 8.